Hello everyone. Today I would like to show you simulation of Lego pieces. So this is the render of simulation I've done. This video will be split into two parts. Number one, I will show you how to convert this a geometry, which is the rubber toy, into Lego bricks. Then I will show you a quick way of set up this dynamic simulation. Consists of all these bricks. And then we will build a glue constraint to glue them together. So only when they hit the ground, so you have this impact, then the pieces will start to separate and collect the ground. Alright, so let's take a look at how we can do it. Okay, first of all, you need to go to allboat.com, which is the digital assets website effects. Alright, yeah, you can search for two things. Number one, Lego brick generator. For apprentice is free, and then you can download this digital assets. Basically, I can generate this type of Lego bricks, the normal bricks, also the plate type, and also the flat tile. Okay, when you flip them over, you can see that the bottom looks like so. Alright. And then the assets can generate 1 by 1, starting from 1 by 1 all the way to 8 by 8. The other assets you need to download from this website is called Legoize. Okay, you can give it a try. It's free to try, and also for apprentice is free also. Okay, basically what it does is to take in the geometry and fill in the geometry with points. So these two assets work together. Legoize will convert your geometry into points. Then you can copy those Lego pieces onto those points. Of course, the points that generated by these assets will have relevant attributes for you to easily decide what kind of bricks type you're going to copy. You can see here you have a normal brick, and also this plate and flat tiles. Okay, so this is another example of a torus. We convert torus into Lego pieces. Okay, once you download these two assets, you can install them into your Houdini scene. Okay, basically this is a new scene. It's an empty scene. All right. So number one thing we want to do is to install the assets library. Can install asset library. To me, I think it's here. I put into this HDA folder, and I download this two digital assets. One is the Legoize, the other one is Lego Brick Gen. You can install them one by one, no particular order. So just install the Legoize first. Accept. All right. Okay. When you open the digital assets, right, you can see what are the assets inside, which this one has only one digital asset. Let's install first. Then we select the other file, which is the Lego Brick Gen. Okay, accept. Right, same thing. There is only one digital asset there. We just install it. So now we are at the object level. Okay, object level. We can drop a geometry node. You can name it Lego simulation. Okay, go inside there. Create a rubber toy. Okay, you press tab. Rubber toy. Yeah, this one, rubber toy. If you want your parameter to park here, you can press P to toggle it on and off. All right, we like to convert this geometry into Lego pieces. And the first thing, we need to take notes of the units. Okay, let me explain this. So we need to drop Legoize digital assets first. Okay, where to find it? Actually, your custom assets, right, will be parked under this digital assets menu. Okay, see here, Lego Brick Gen and Legoize. So let's create this one first. Okay, when you create this, you can see that actually this node has quite many documentation here on the nodes itself. Okay, so basically what are the things to note is this very importantly, the assumption. Okay, this tool assume that one Houdini unit here is 1 mm. This is more for us to, when we do modeling, we don't want to model something like 0.0008 or something to have a very small number. So we just take one unit as 1 mm. So it's then we will leave the user to scale up and down depending on what size you need. But we assume that one unit is 1 mm here. All right. So which means that the simplest Lego brick 1 by 1 is 8 mm by 8 mm. If you look at the bottom square shape right here. So here we assume that it's 8 Houdini units. All right, by 8 Houdini units. It's quite big, I know. Yeah, but then you can scale it down based on your need. If you really want just 8 mm, you can scale it down by 1,000. Okay. All right, then this tool support this 3 types of bricks, as I mentioned: 0 for brick, 1 for plate, 2 for flat tile. Okay, if you have this in mind, right, that means that if you directly connect this to the Legoize, most likely you're going to generate only 1 point here. Right, you can see. Okay, let me change the background to be dark. This means that because the Lego piece is quite big, it can only fill this geometry with 1 piece only. Yeah. So what we need to do is to select this rubber toy and change the uniform scale to be 100 to start with. Okay. So the rubber toy has been scaled up for 100 times. Then when you connect Legoize, now it can fill the rubber toy with a decent amount of points now. Okay, which is very good. If you look at the documentation, right, it says that actually it can inherit colors from the geometry, point colors, but it looks like it doesn't do so. That's because for your geometry, even though when you display your geometry, it looks like colorful, but actually they are textures. They are not point colors. So how to convert the texture into point colors? Drop attribute from map node here. Okay, put it here. Make sure that it's connected. If you look at the rubber toy and unlock it, basically allow edit, all right, of this asset, right? You can dive into that, right? You can dive into this network and take a look at where is the texture, right? So this is the material principal shader, right? And if you look at the textures, you know that actually this picture, this image was embedded into this digital assets itself. We can copy this path, then go back to a geometry level. Okay, then you look into the attribute from map, right? Then we can fill in the map with this path. But again, you know that Houdini is using a folder hierarchy system. Then we need to do this way. So we need to tell that you go back 1 level, // right? If you're familiar with command line, you know that // means go back 1 level. Then we are going to look for text geometry rubber toy 1, right? Where do you get this name? Actually, this is the name of this node. Okay, yeah. If you know that you have if you work on your project, you have a texture on disk somewhere, you don't need to use this opdef. Okay, you can just directly browse using this dialog to choose texture from disk. Okay, but if you look at point color, right, it's not as detailed as this one, the texture. That could be because when you look at the resolution of the geometry, right, point color only have color on the points, so it doesn't have color on the polygons, on the primitives. So if you want to have more detailed color, probably what you can do is increase the resolution or the density of the polygons, okay, by connect subdivide node. You see here, it suddenly become a lot more dense polygon. All right, now if you apply the attribute from map, by the way, by default, a export a color CD. CD stands for color. Now, if you try to update to display the Legoize node, you can see that all the points suddenly has color now. Okay, the other thing is that I would like to bring up the Geometry Spreadsheet. Here you can clearly see a lot of information that has been added to the points also. Say, for example, the brick type, color, name, top brick, if the point is at the top, the resolution of each brick, I say 2x4 or 4x4, or those kind of bricks, right? Yeah, you can see the information now here. This are all determined by this Legoize node here. All right. So now let's create some Lego pieces and copy to those points. Okay, so what to do? You can go to digital assets, create a instance of this Lego brick gen. Right. If you only look at this node, right, it's generating. It's a modeling node to generate some Lego pieces, right? Of course, this is a much detailed version. You can turn off the subdivision. You can turn off the bevel, so you can end up with a very low res geometry. It's very good for simulation. Okay, of course, you can also change the how many FLU are there. Say 2 units. All right, you see here 2 FLUs, or 3 or 4, up until to 8, and that's in the main direction, which is the X direction. And also you can have the other direction. All right, so say this is 2x8. Of course, it can support up to 8x8, but maybe in the real world there's no such thing, but it provides the possibility. Okay, so this is the number 1 brick, which is type 0. When you have type 1, this is a plate version of that. And then when you go to type 2, which is the third type, you have this flat tile. Okay, all of this have subdivision and bevel if you want. Okay, so you have bevel edges. All right, so we're going to copy this onto the points based on the point information here. You can use multiple ways of doing that. I think the recommended way for copying the geometries to the points, we can use a for loop combined with copy to point node. All right, so what we can do is this. So we will just to drop for each point. For each point of this point that generated from Legoize. For each point here, we're going to do something. We're going to do what? We're going to copy this onto the points. Okay, so we need to use a copy to points node. Okay, then we can connect this Lego to that. All right, then you can probably see that. Okay, so this is the. Oh, sorry. I did the wrong way. You can press Shift R. Because the first input should be the geometry to copy. All right, geometry. We're going to copy this Lego piece, okay, which should be the first input. The second input is the target point to copy to, right, which is the which should be the point that generated by Legoize. Okay. Okay. Now when you display, you should be able to see something, but you don't, because I think the Lego pieces are really tiny. Okay, we need to scale it up by put down a transform node. We need to scale it up to 1000. All right. Okay, then when you copy to the points, it looks like something is happening, but not ideal because we are only copying one type of brick to all the points, right? But we should generate different type of bricks based on the information on the points, which is the brick information and this information here. Okay, XY units. For loop, we will iterate through all the points one by one. Each time we'll take one only. Okay, this is for each begin. We will have that point. If you click here, right, you should be able to see one point only. All right. We need to use an expression to access that point. We need to use a point function. Okay, sorry, point around brackets. Okay, we're going to access. We're going to access which point, which node. The node is for each begin one. Okay, each begin one. All right. And if you look at the help, it says that the first one is the node. The second one is the point number. Because for each point, right, we only have one point. So the number will be 0, comma, attribute the main direction, which is the x direction. So I know that the attribute will be x resolution. And then because then the last one is the index. If you have a attribute that is a multiple component, right, you need to specify which one you're going to access. But for us, it's only integer, so of course it's only have one, which is the 0 index. Use a similar expression for the z also, right? You just copy and paste the expression from the first parameter to the second and change this to z resolution. Then you also need to do the type switch. Then the type switch will be the brick type. Okay, it will take a while to cook, but once it's finished, I think this is perfect. Okay, let's make this view a little bit larger. Okay, you can see that let me turn off the grid. Also, let me turn on the subdivision and the bevel to have a more detailed version of the Lego bricks. Okay, so cook finished. And you can see that the Lego bricks really looks nice. All right. It will consist of normal bricks, and it also has a flat tile type, and it also has this plate. All right, so this is working now. Looks nice. But if you want to just have this modeling, then you can stop here. That is done already. But if you want to follow my video here to simulate it like what I've done, what I've shown you at the very beginning of the video, then we just need to do a little bit more work here. All right, so next thing we want to do is to feed this into a DOP network for rigid body simulation. So what we can do is this. Okay, if you turn on the grid, right, you may look like this this thing is really huge. Now it's like 100 meter wide. Okay, even though maybe when you're modeling something, the unit doesn't matter that much, but for simulation, it's very critical because if this is 125 meter wide, right? When you simulate in Houdini, the thing, it really looks huge, and the thing will fall onto the ground driven by gravity very slow because it's 100 meter tall. Imagine you drop something from 100 meter tall and take a while to drop on the ground. But if it's only 1 centimeter, right, when you start to simulate, it will just immediately fall on the ground already. So that's one thing that we need to take into consideration, which is we need to scale it back. Okay, yeah, for simulation you need to scale it back. So let's drop transform node. I would rather go scale it back down by only 100th. Okay, so this thing I need to scale it back. Right. Then because half of the body is under the ground. I would like to bring it up so that when we create the ground, we don't need to move the ground itself. So you can do another transform node, yeah, just to move it up. Okay, so it's off the ground. Then we can feed this into a DOP network. Okay, feed into a DOP network. But before we actually build the rigid body in the DOP network, I would like to show you something. The thing is that because this is the high resolution geometry, it has a lot of geometry details. For this example, might be okay to manage, but for in case you have a very heavy simulation, you don't want to directly fit this into the simulation. You want to fit the simplified version into the simulation, then you use the result to drive the high resolution. So I will show you that technique as well. So here, if I want to simulate the low res, right, I need to turn off the subdivision and bevel. Okay, right? Yeah. Now, if you look at this scene, is quite light. You need to fit this into the DOP network. All right. What we need to do is go inside the DOP network to use a RBD Packed Object. Okay. So if you type RBD Packed Object, all right, then you need to connect a solver, RigidBody Solver. Okay. That's the minimum requirements, I think. You need to have the container, which is to contain the Lego pieces. Then you have a solver, right? Then of course, if you want to have some gravity, you need to have a gravity force, like so, right? Gravity force. So now I want to put in a ground plane, and then I need to merge this ground plane into this network. And this thing here, there's one thing to note is that if the order of this wires going to the merge, right, is very important, because by default it says that the left inputs affect the right inputs. The right will not affect the left. So if you have something like that, right, the ground plane is on the right hand side, then your geometry will not collide with the ground, even though it put on the left hand side, but it's wired into the right side. It won't work. Okay, so you need to use Shift R to swap it, or you can use this UI here to swap it. So the left ground collider will affect the rigid body on the right for this merge node. Okay, we haven't brought in the Lego piece into the RBD container. Okay, can you select this RBD Packed Object, and we can just specify the geometry source to be the first contact geometry, which is if you go back, which is the first one that fed into this DOP network. We need to create those packed objects that needed by RBD Packed Objects. Okay, so before do that, we need to think about our strategy. If you look at the node, right, Houdini provide this node called assemble. Okay, this node will help you to create packed geometries. Okay, and it will also create those name attributes. Name attribute is very important for Houdini to recognize pieces. If the two pieces have same names, then they will be considered as one piece. Okay, we will be simulated together as one piece. So this is very critical, because you know that one Lego piece have multiple parts. Let me show you. If you look at the okay, like this one doesn't have. Okay, let me show you a example. Let me just quickly drop a Lego brick gen. when you have multiple units in X and Z, then you end up with see you have one piece, and then inside here you have this tubes, right? They are all separate geometries, okay? But when they are modeled, so then the problem is that if you directly use the sample node to create name attributes, and each one of these will be separate, then when you simulate, all the tubes will fall off from the Lego piece. So how to make them together is that when you copy the Lego pieces to the points, right? Okay, see here. When you use copy to points, actually you can copy the name attribute from the points to the primitives. All right, because Legoize node provide you, okay, if you select this, the Legoize node will provide you with the name attribute on the points, but not on the primitive. See the P0, 1, 2, 3, 4 for each individual points, right? Then you end up with your primitive have a name attribute as well. Okay, let me cook it first. All right, yeah. Once you have that, then we need to turn off this create name attribute from the assemble node, because we will use our own way of creating primitive names instead of let the assemble node to create for us, which is not accurate here. All right, so next thing we want to do is to just go back to the simulation, to the DOP network, and then let's see if that is working or not. Yeah, it's working now. But this is not interesting because it's just settled into all these smaller pieces. We can do something here. For example, I would like to have it to move in one direction. So I need to assign the initial velocity to it. For example, I will give it give a speed of 10. Okay, so at the very beginning, all the pieces will have this velocity in the Z direction. Yeah, now you see that they go into this Z direction, and then they collide with the ground. Okay, it's quite cool, but still we don't want all the pieces just settle like so. I want some of them are glued together. We need to build glue constraint. What you need to do here is to actually create some constraint lines at the sub level. Then when they are brought into the DOP network, they will work as constraints. Okay, so we just need to create some lines in between the center of the pieces. So one thing we can do is just use Houdini default tools like connect adjacent pieces, which will, okay, if you look at this one, go to frame 1, look at this node, it will create line segments to connect pieces. Okay, remember that we already packed the geometry, so the geometry become a point, basically a point to represent one piece. Then you end up with a lot of pieces here. All right, see here you have this 9, 8, 7 points. Each one of them to represent one packed geometry. Okay, then Houdini know where to look for the geometry. If you try to connect those points together, so you can say maybe I want the point to connect to more neighbors, right? Say maybe 4 neighbors. You can also increase the search radius, all right, to search for neighbors to connect. All right, so maybe like 2 point. Yeah, this number is good. Okay, so we create all these points. So I think all the pieces should be connected somehow into this whole wireframe. The other requirements for us is to add some attributes to those lines so they can work as constraints. Okay, so you can do a attribute create. At least you need to create this constraint name, and it should be a primitive class attribute. Then it should be a string. Okay, in that case, I can call it Lego glue. Okay, Lego glue. I need to feed this into the second input of the DOP network. Okay, display this and go inside. Okay, inside here, I can connect a constraint network which will bring in the lines we just created just now. Okay, so for the geometry source, we can just say the second context geometry that fed into this DOP network. But then we need to specify what kind of constraint network it's going to be. I'm going to use glue constraint relationship. And for this glue constraint relationship, the only thing I need to change is to tell the solvers that you need to look for Lego glue, right? Remember just now we assigned Lego glue names, constraint names to the lines, and I'm asking Houdini to look for those lines to use as glue constraints. How do you know that this is working? All right. So one way is to turn off the display of the RBD Packed Object. And if you can see the red lines here, right, that means your glue constraint is working because they are in red color. Or you can change to other color as well. Okay, anything you like. For example, green, then you know that these green lines are glue constraint networks, which means that it's working. So we can display back the geometry. All right. Now let's take a look at the simulation. It's much better. All right. So the pieces will shatter, will separate from the main rubber toy. When the object hit the ground or hit something and or have any impact. But this is a little bit too little. I think it's because the glue constraint is too strong. Let me reduce. Yeah, I think this is something that I did for the rendering, the simulation I have shown you at the very beginning of the video. All right, so when you take a look at this, okay, it's quite interesting. All right, so that's pretty much the simplest setup I can think of to demo how to convert geometries into Lego pieces and how to set up a simple RBD simulation to simulate that. But as I mentioned, right, if you try to render, right, they are still in the low res. How to make them into high res? We need to do a little bit extra work. Okay, so bear with me. So let's finish that part. Okay, let's move this to the right side. Okay, this is the simulation. This is the simulation, but we need high resolution. Of course, multiple ways to do. One thing is that you can cache this into onto disk and use this data to drive the simulation. Of course, you can do another way. Okay, I'm showing you how to do. Is that I'm going to exactly duplicate this. Okay, I select this node. Right, I'm going to hold down Alt key and just drag and create another copy of all these nodes. I can check if everything is working fine, right? By looking at the node, it looks fine. It's just low res, right? Yeah. But we need to select the new Lego Brick Gen node to turn on the subdivision and bevel. Okay, it will take a while to cook. Okay, now it's in the high res. All right, geometry. Then I'm going to use a node called transform pieces to drive the high resolution pieces using the simulation, which is fed into the second input of this one. Okay, yeah. All right, then in the end, when you zoom in, you should be able to see the pieces are in high res. You can see verified by turn on the wireframe mode. And the simulation data was brought in from the DOP network simulation. Okay, yeah. Okay, so that's how it worked. All right. Of course, it's strongly recommended after you simulate everything, you need to cache the simulation to disk, because when you do loop development, when you do rendering, okay, and when you scrub the timeline, when you close and open the file again, you don't need to resimulate, right? Yeah. Okay. So that's all for this video tutorial. So hope you like it. Enjoy the simulation, and see you. Bye bye.